Children, once again welcome to our physics class. In the previous sessions we had discussed about optical instruments and we discussed one of the optical instruments, that is microscopes. We had discussed about simple microscope and compound microscope. Today we will discuss another optical instrument, that is telescope. To be more specific, we can call it as an astronomical telescope. So what is the purpose of astronomical telescope? See, astronomical telescope is used for observing distinct images of heavenly bodies like stars, planets, etc. You have already known about the use of astronomical telescope. Why do we use astronomical telescope? In order to obtain a duly magnified and resolved image of far off celestial objects. Okay, and what is the theory? This astronomical telescope has two convex lenses separated by some distance. So, two convex lenses are there, just like compound microscope. It has two convex lenses separated by some distance. The lens towards the object is called objective lens. So, here, this is the objective lens. Here, we will consider our object. The lens towards the object is called objective lens, and the lens towards the eye is eyepiece. So this small lens, the small convex lens will be the eyepiece because this will be the lens towards the eye. Objective lens has larger aperture than eyepiece. So as you can see here, this is the objective lens O, this is the eyepiece lens E, and objective lens has larger aperture than eyepiece lens. Okay. So just the reverse of compound microscope. In a compound microscope, eyepiece has larger aperture than objective lens. But in telescope, objective has larger aperture than eyepiece. Can you say the reason for this? This is because this objective lens focus at far off celestial objects. So it must collect as many rays as possible from that object. So for that, the objective lens is of larger aperture than the eyepiece lens. Okay. Now, we can discuss about the ray diagrams. So first we will discuss the setting of astronomical telescope for relaxed eyes. Okay, setting for relaxed eyes. Setting for relaxed eyes means what? Image should form at infinity. That is the setting for relaxed eye. Image should form at infinity. Children, so we can discuss the ray diagram and we can draw the ray diagram showing how image is formed at infinity in a telescope. Okay, so first we can represent the rays coming from the object. So we have object at infinity because you know the celestial objects will be at infinity. So we assume that the objects are at infinity and from infinity parallel rays will come. So parallel rays are received by this objective lens. Objective lens focus at the object and our objects are at infinity. So parallel rays are received by this objective lens. Now suppose this is one parallel ray and consider another ray which pass directly through the center of the lens. Let this be C1 and let the center be C2. Now consider another set of ray which will move like this. Okay, so these are the three parallel rays received by the objective lens. And many, of course, many rays are there, but for our convenience, we consider only three rays coming from the object. So our object is at infinity. And these are the rays received from the infinite object. Now you know this ray passing through the center of the lens will pass without any deviation. So this ray will go straight like this. Okay, without any deviation, it will move without any deviation. Now, this ray will bend and it will suffer the refraction like this. This ray will also bend and suffer refraction like this. So these are the three refracted rays. And these three refracted rays meet together at this point. So here you will get the image. Of course, you will get a real inverted image, and this is denoted by A dash B dash. Okay, so you will get image at this point. Now, this point will be the focus of objective lens, isn't it? Because in class 10 physics you had already studied, whenever the object is at infinity, image is formed at focus. So here our object is at infinity, so image will be formed at the focus of this objective lens. So this point where the image is formed will be the focus of objective lens. So FO means focus of objective lens, and we are getting a small inverted image, isn't it? Object at infinity will be very large, and we are getting a very diminished and inverted image of that infinitely large sized object, and this is our image A dash B dash. Now, if two lenses are there, image formed by the first lens acts as object for the second lens. We had already discussed this concept in our compound microscope. So here also two lenses are there. So image formed by the first lens, that is our objective lens, will act as an object for the second lens, that is for eyepiece. So this A dash B dash, which is the image of first lens, will be an object for the second lens, that is eyepiece. So here also we consider two rays. One ray which pass through the center of this lens and it will go without any deviation, and another ray, let it be a parallel ray like this, and this parallel ray after refraction will pass through a point, and which is that point, it will be our focus, isn't it? So this will be the focus of eyepiece lens. Now look at these two rays. These two rays are parallel rays, and here will be our eye, here will be the observer. So that's why we call this as eyepiece. This lens is near to the eye. So these are the two parallel rays, and these parallel rays are assumed to meet somewhere at infinity. So we don't know that. So we will backtrace this rays. Just backtrace these two rays. So whenever we backtrace these two rays, we can see image. Image is somewhere formed at infinity. So the eye is focused on infinity. So the eye muscles will feel relaxed. So here eye is focusing on infinity because eye feels that, or observer feels that these two rays are coming somewhere from infinity, not from here. So here image is formed at infinity. So if image is to be formed at infinity, where should be this object? See, for this lens eyepiece, A dash B dash is the object, and the image formed by this eyepiece is at infinity. So when do this image form at infinity? You know, image is formed at infinity whenever object is at the focus of the lens. So here A dash B dash is the object of eyepiece, and image of eyepiece is formed at infinity. So this object, that means the object of eyepiece, should be at the focus of eyepiece. So this point is the focus of eyepiece also. Okay, so in the case of telescope, in the setting for relaxed eyes, the same point acts as the focus of objective and the focus of eyepiece. That means the focus of objective and eyepiece coincide. That is the condition, because here this is the object of eyepiece and image of eyepiece is formed at infinity. So if image is to be formed at infinity, object should be at the focus. So here the object, that is A dash B dash, should be at the focus of the eyepiece. Then only image can be formed at infinity. So the focus of objective lens and the eyepiece lens coincide in the case of relaxed eyes setting. Okay, so final image is formed at infinity. Now we can discuss the magnifying power or magnification. And you know what is magnification? Magnification is the ratio of angle subtended by the image on eye to the angle subtended by the object on eye. So here, which is the angle subtended by the image and which is the angle subtended by the object. So here you can see the rays coming from the object. These are the rays coming from the object, and let this angle be alpha. If this angle is alpha, then this angle also will be alpha. Vertically opposite angles are equal. So if this angle is alpha, this angle also will be alpha, and this is the angle subtended on by the image, subtended by the object on eye. So this is alpha, that is angle subtended by the object on eye. Then this is our image, A dash B dash, image of the objective lens. And what is the final image? Final image is formed at infinity. So final image is somewhere at infinity. And just consider these rays. These rays subtends an angle here, and this is the angle subtended by the image, because these rays appear to come from the image at infinity. So these rays form an angle here, that is on eye, and let this angle be beta. Okay, so this angle is beta, this angle is alpha, and this is the angle subtended by the object on eye, and this is the angle subtended by the image on eye. And what is magnification? Magnification is beta by alpha, angle subtended by image on eye divided by angle subtended by object on eye, beta by alpha. And since these angles are very, very small, we can apply the small angle approximation. So beta can be written as tan beta and alpha can be written as tan alpha. So beta by alpha equal to tan beta by tan alpha. And from the figure, just find out an expression for tan beta. What is tan beta? So this is the angle theta. In order to find out an expression for tan beta, just consider this triangle A dash B dash C2. A dash B dash C2. And this is the angle beta. So tan beta is opposite side by adjacent side. Opposite side is A dash B dash. Then adjacent side is B dash C2 by tan alpha. This is alpha. We can consider this angle alpha. To find an expression for tan alpha, consider this triangle. Triangle A dash B dash C2. A dash B dash C2. Okay. So this is alpha. Opposite side is A dash B dash. Adjacent side is B dash C1. So here opposite side A dash B dash and adjacent side B dash C1. And here we can cancel A dash B dash, A dash B dash. Then we are left with 1 by B dash C2 by 1 by B dash C1. So taking reciprocal and by suitable rearrangement, we will get B dash C1 by B dash C2. Now let's find out what is this B dash C1 and B dash C2 from the figure. What is B dash C1? B dash C1. This is the distance B dash C1. Okay, so this point is the focus of objective. And B dash C1 is the distance between focus and the lens and the center of the lens. So the distance between focus and the lens will be the focal length. Okay, so this distance B dash C1 is the focal length of objective. So B dash C1 focal length of objective. What is B dash C2? B dash C2. This is B dash C2, this distance. Again, this point is the focus of eyepiece also. So B dash C2 will be the distance between focus of eyepiece and the eyepiece lens. So this distance will be the focal length of eyepiece, that is FE, focal length of eyepiece. So B dash C2 is the focal length of eyepiece, FE, and apply the sign convention. So this FO is measured to the right of the lens, so it will be positive. But FE, focal length of eyepiece, is measured to the left of the eyepiece lens, so FE can be taken as negative. So the magnification of telescope for setting of relaxed eyes is minus FO by FE. Okay, so magnification M is equal to minus FO by FE, where FO is the focal length of objective and FE is the focal length of eyepiece. And from this expression it is very clear, magnification depends upon focal length of objective and eyepiece lens. Okay, so if M must be high, or if magnification is to be increased, then increase the focal length of objective and decrease the focal length of eyepiece. So that's why objective lens is having more aperture, larger aperture than the eyepiece lens. Focal length of objective is more than the focal length of eyepiece in order to obtain best magnification. Okay children.